Hello everyone, and today I'm going to show you how to create simple to-do app with clean architecture without any boilerplates. And I've seen a lot of videos out there in YouTube that there's a lot of people with a lot of subscribers, a lot of views, showing people not properly things because they're creating something and they call that clean architecture. They're like using BLoC, some creating some folders. Not folders is not about the clean architecture, but files, some kind of things that which is not. I would say it's not clean architecture, and they're creating some kind of things that which is not useful or usable in clean architecture, especially in Flutter. For example, I've seen some people that they create I would say use cases which is not necessary. Yeah, it's necessary if you're creating some backends which can do which can connect some repositories there, but it's not useful in Flutter in front-end side. I would say in a UI side where you show, where you just make a request to the server. It's not necessary. So that is why today we are going to use some packages, and in the end of this video I will put some links in order to show you some good examples, good experience of people which they have a lot of great experience in Flutter, and I will share the links in down below to this video's description. For example, there is a Flutter. We will use Flutter BLoC, and I'm going to show you using BLoC without any code generation. For example, freeze package helps us to not write a lot of code, and but by the end of this video, when I finish to show you how to use BLoC without any freeze, I will use this freeze in order to show you how you can use that. It's simple application. It will not take a lot of time, and if you follow this instruction, all instruction that I use, probably there will not be any problems there. But it's a simple application. It doesn't have any authentication, some kind of things. We will use Drift as database, local database, and this Drift uses SQLite on top of this SQLite, which is very good. There's a lot of packages like Hive, or maybe some kind of this, which is people call it the local database, but it's not a database. It's I would say it saves data in memory. That is why it's not a good thing to use. Also, there is Hive Flutter, and there is also some kind of local storage, some kind of thing. I don't remember. Yeah, local storage, which is exactly the same as Hive. Also, it's not recommended to use, especially if your project is like small. Instead of using like local storage, yeah, you can use local storage and Hive, but instead of using them, you can use shared preferences in Flutter. It's much more better, it's much more easier. And as I mentioned in previous videos that I recorded, that the main thing of writing code in application is that you can write tests for your application. It's the most necessary thing. For example, if you're writing a code which is not testable, it means that your code can't be maintained by other people, like it can be scalable, like some kind of thing, some sort of problems will happen in the future. That is why let's start to creating our application. Our application, just simple one, like this one, like this phone one, and I don't have any templates. That is why we will start from scratch, and I don't have any logic of this. For example, a lot of people do this, that they have some templates and they will look to their code. I will look to my codes, some kind of initialization of code, some kind of things, but I will not look to that. I don't have any like the ready code for this one. That is why let's go. First of all, in a clean architecture, there is some kind of folders exist there. For example, a lot of people do this one. I will explain you. I will create source. For example, source, it means that it's your root of your application, everything that there is inside of that. For example, there is another applications that I've worked with. They have like localization, maybe some kind of things, and they're not inside. Like they're not inside source. Wait a minute. Excuse me. Yeah. What I was talking about. So there is a source folder, which is, I would say, the main application. There is a features, core, common, or whatever you call, like this kind of folders exist there. And so in this library, like you can create generated, like localization, some kind of things. That is why in source folder we will create features, and also we will create common. Or we can call core, maybe. Doesn't matter how you can call it, but you can call core. So first of all, let's go and create our initialization. Our main screen, which we will call to-dos. Okay, and also there is a to-do like this one. So what does it mean? So 3 folders there we will create. Yeah, the to-dos means the main screen. For example, you will go inside of this application, and you will see that there is all to-dos that you can do, your remaining to-do 3, for example, yeah, and some kind of things. And there is also your to-do. There's another screen. There will be another screen that you can go inside and create your own to-do there. New to-do, I would say. So, okay. We'll remove all this and just remain this like this one. We don't need this widgets anymore. If in the future I'm going to create tests for this project, for this simple project, and yeah, I'm just going to show you how to write tests properly, and that's all. So let's go. First of all, I forgot to do some things. Let's add all of this all of these packages. You can use only one of these blocks. You can use only Flutter block if you're using a Flutter project, and you can use or you can use this block, this one. It doesn't matter. I just added both of them. Just do that in your own mind. If you want to use them, just Flutter block is just enough to use. We will not use freeze right now, but in drift documentation, there is dependencies that you can use. So that is why copy it to this clipboard and paste it in your terminal in order to get all of necessary packages. So BLoC, drift Flutter, path provider, Flutter lanes, drift, dev, build runner. That's all, I guess. Okay, that's all for now. Okay, so we add this one, we added build runner, and I guess that's all clean. Okay, start to create our application. First of all, we will start from initialization. Okay, let's go and create, I would say, okay, what I wanted to say, because of that our project has dependencies, like dependencies that might be used in whole application, like repositories. Maybe you are using some controllers, maybe some blocks, doesn't matter what it is, just if you're using them and if you want to use them in a whole application, so you can create dependency container there. Dependency container, it's some kind of thing which you can use with inherited widget. And as you might know, that inherited widget, some kind of things that can pass your containers, doesn't matter, your objects down to the widget tree. And that is why in initialization we are going to create some logic that will initiate our application. In order to initiate our application, you have to use our dependency. What kind of dependency we will use, what kind of repositories, controllers, what kind of like dependencies. All of this stuff is about dependencies, initiating dependencies and start our application. First of all, that is why we will create model, and we will create widget. This widget thing will hold like material context, root context, all of this. So we will create material context, material context. So material context will give me a second. So there is a stateful widget which is material context. It will be the material app, material app, it will contain all of the stuff of I would say the initialization of our application with Material app. For example, if you have any theme, any localizations on any roads, you can use all of them here. Not right inside main, yeah, but here. So let's first of all configure our application size, screen size, especially about the text scaler. For example, there will be, I would say, moments that people which have not good view, like some people which some sort of blind, or maybe they can't see normally. They can scale the applications, the whole phone's phone size, and that is why this kind of people can see normally. That is why in your application, when they enter the application, they will see a lot of like larger text, the large text. That is why, in order to not happen that, to avoid some kind of situations, you have to control them. That is why, first of all, let's take our media query, okay, and then let me write this one here, just for a second, and then in the end I will explain you what's happening here. Media query, like there's a child, so the child, our child should be the distance, so data is media query, copy width, text scaler, media query, text scaler, scale. So it should be about like 1, or 2. It's 1. It's normally it's good, I would say. So scale. Why it's not okay? Like this one. So all of the people which don't have a good view, or they don't have, like they have a problem with their vision, I would say, and a little bit with their problem with their eyes, they can see normally, and they can scale their text in their application or maybe in their phone, so they can see what's happening here. The people which wear glasses, excuse me for my English, first of all. That is why they scale their font size of their phone, and when they enter the application, they see that all of the text in your application just very large, and it will be the reason of some kind of errors, Flutter errors that happen in your application. That is why, in order to control them, we will write this one. For example, there is you wrote in your application that the text size will be 14, but actually after changing the text size in the settings of application, settings of phone, this 14 will be very large. That is why it will be 20 maybe, and that specific place which your text keep specific place, specific widths, it will be out of the boundary, and it will contain a lot of like errors. That is why we will create this one, and then we will add our home, but right now we will just write scaffold for now. But after adding some kind of features, introduce some places like this one, we will change our scaffold. So let's go. So we will do, also we will create the root context. Root context, stateless. And just for a second, scaffold. That's all. So I've seen that a lot of people, it's good to use that. For example, the Flutter BLoC has, I would say, has its own root context before material app. You may see, you might see that, you might have seen that people use Flutter BLoC's multi-block provider, so block provider, some kind of things, in order to just pass their blocks down to the widget tree. So it can be visible in the whole application. Yeah, it's good to use multi-block provider, block provider. It's very good. I'm not saying that you can't use that. I'm not saying that you can use that. But in this application, instead of creating some multi-block providers, so passing the dependencies down to the widget tree, just all of the widgets, instead of that, we will do another thing. So there is a dependency container which holds all our dependencies, like dependency container, class dependency container. So there is another some kind of things in testers you may use base class test dependency container implements dependency container. No such a method. It's no such method. Yeah. So it's not necessary for us. Only visible for testing for foundation. It's not necessary for now. You just now write this one right now, but it's not necessary for now. It's not necessary for now. But in the future, when we will write tests, we're going to use this one. It's very, very useful for tests. So you have a dependency container which may have dependencies, doesn't matter, repositories, controllers, blocks, doesn't matter. But you have to use that blocks, controllers, that especially people use dependency container only for like some, I don't know, some kind of repositories, maybe some kind of stuff, logger, shared preferences, some kind of things, some classes that may use for the all application. But you may ask that what happens if I use like service locator, maybe, or like singleton. I would say that singleton is very good to use for example, yeah, but I'm talking about dependency injection. Dependency injection is very useful when you want to write tests. If your app, if your application, if your code was written in a way that you can't write tests, it will be very bad. Believe me, it will be very bad, because it means that some kind of another developers that can come to your application, to come to your project, and they will notice that, or that some kind of good developers that they come to your application, to your project, and they will see that they can write tests. It will be very bad, because somehow your application should be written, your code should be written in a way that you can write tests. So just let this one be here just for a second, and so dependency container. So we will write our initialization first of all. And you know what? Let's go and add Flutter logger. So also we added our logger here. So let me grab some kind of code from my previous projects, which is already written. You can pause the video and write all logic that I'm writing. So where is the Give me a second, brothers. Okay, let's go and create here utils. And let's go create UI get here. But it's not necessary here, I guess. Just remove this one. Right inside here, yeah. Create package, which we'll call database. We'll call that BLoC observer. Database extensions constant. Okay, so we will write database BLoC observer. There's only one thing. Okay, that's all for I guess. Database. So in the futures we will go create model and there's a logic. In logic we will create in the logic side we will create composition root, okay, and app runner. So there is an app runner which is going to run your app, or maybe just run, it's enough. So, and a lot of people may think that why you are not writing your run. Maybe let's go class app runner, yeah. It's much more better, I guess, than this one. And run zone guarded. So you may ask that why you're not why you wrote run zone guard. What is the reason of that you wrote run zone guard? It's because of that run zone guarded. It will handle all of that exception that you not cached, that you not caught. Look, for example, you have a try catch, and inside of try catch you will write code inside try and catch. You will not you will use some kind of catchers, yeah, and you will write error throw with stack traces, some kind of things. And if you do not do this, if you don't use any try catches, all of that exception that not be handled there, all of them will come here, right here. And there is why. There is why this kind of things, which is necessary to do, especially around zone guarded, will handle all of that exception that try catch, even try catch can catch. That is why around zone guarded it's very useful to use. And let's do some another thing. So we'll write our initialization. So widgets flutter binding, yep, initialized, and you have to use some kind of Flutter error logger, Flutter errors that for example, you have some kind of errors that should be caught in your application. You can use this one, like for example, Flutter error. So let me just see real quick. So this one, which is not necessary to you for a while, for now, and also this one, which catches all platform errors that may happen in your application, and that's all. And that's all. Let's create our logger first of all, which is very necessary. Logger. Composition root. So here you can do what you can do. Composition root. You can write some kind of thing from class composition root. Just you can select this one maybe, and end. Do you know what? Which is better to do? Just do like future. Composition result. I guess it's better. Yeah, class dependency composition root. So final dependency container, and composition root. It will return dependency container here. So we'll do some kind of class composition. So now composition future. So composition root. So we will create another thing. Future dependency container. Create dependencies. Just give me a little. Just give me a minute, I will come back. So dependency, create dependencies, we will use this function in order to create dependencies. For example, as you might see that we have a model class here, this that calls dependency container. Dependency container will have, as I said, a lot of dependencies inside. So in order to create a dependency and use for whole application, we'll do like this one. Create dependencies. So what should this one will do? For example, just for now, just return dependency container for now. And in the future, when our application like starts to, do you know what, this dependency composition, which I guess not necessary for now, just we will comment this for a while. Oh, there's only one thing, which is create dependencies, and it's for now it's only the one thing that you can use. That is why let's create our logger. Okay. Okay, we have there's some kind of things. Just stop your video and just rewrite all this logger. Okay, because this logger okay, so what we can do here, we can do some kind of thing, required BLoC filter. I used this one in my previous projects. In the previous project, I used this one. Let it be here. All these comments, let them be here. So there is a create app logger, which will create our logger once in application, and that after that we will not use that anymore. Not create logger anymore. That is why it's better to use. So as we created our logger, we'll go to our dependency container and we'll write like logger, and or you may ask, what is the reason that you're creating logger here? It's because of that this dependency container will be used for whole entire application, and we can use that logger for all application, for the whole application. That is why dependency container in here is getting some errors. That is why you can do what you can do. Okay, you can do like a logger. Create app logger, and we will say that as our application may run in debug mode and release mode. So in order to not log all these loggers that you can see in application runner, that's like a terminal, you may see them. If it's in release mode, you don't have to show them, because if someone else just grabs a USB cable and sets them in their phone, and checks just whether this application wrote in Flutter and they want to see logs, they can see the logs. That is why if the application in release mode, you don't have to show them that it's running in release mode. That's why we will say that if application in release mode, you'll use development filter, otherwise no filter. Okay, just stop your application, just stop the video and just copy all of these things from here till here, and use for the dependency container. So this is our app logger. That is why we will go here, and what we can do here. So as we created our logger here, we don't have to do this, I guess, here. That is why we can copy this and write here logger, and we are saying that when we create our dependencies, we'll pass the logger here. So logger is logger, and here you can write your final logger. So you can use this logger in your application. This here, the app runner, the logic that runs your application. So we created the logger in order to see what's happening in our application. So whenever there is a Flutter error that happens in your application, you can use the logger in order to see what's happening here. And inside here, you can use like Firebase Crashlytics in order to send some kind of errors to the server. Just let me show how you can use that. For example, you may have Firebase in order to send your errors. Yeah, or maybe this is another one. So you can send your errors to the server, to the Firebase Crashlytics like this one, if Firebase is not catching your errors. So in the end, also, you can send your errors to the Firebase, saying that if it's car release mode, yeah, it's release mode. If it's release mode, so you can send to the Firebase your error. Yeah. What does the run zone guarded do? As I said previously, run zone guarded some kind of things that is much more better than try catches. For example, if you are using some kind of durations, future durations, which is not, try catch cannot handle them. For example, you wrote try catch, but after specific duration, your code will throw any error, but try catch can handle it because there's a synchronous code and asynchronous code. If you used your features like synchronously, yeah, without awaiting, without some kind of things, without awaiting, not synchronously, you use that feature without awaiting, it may be the reason of not catching the not catching the error inside the try catch. Let me just show you what's happening there online. Okay, so there's a main, yeah, main. Also, there is a okay, check try catch. If you do, for example, print starting code, yeah, if you do something like this one, look. If you do something like this one, you can see exception here. Some kind of exception that this is. exception is bad state. Try catch is catching error. Okay, your app will handle that. Your code, this try catch will handle that because it's awaiting. But what if you will remove this try catch, and after specific duration of time, this kind of error will happen in your application. So let's see. Do you see? No error is happening in your application. That is why, in order to catch them, in order to catch this exception, you see that this exception is not showing here because after the specific duration, it's sending throw set errors is happening here. But because of this, the main, this catch error, this state error, throw exception is throwing this to the main, not inside the catch. Try catch is not handling that. That is why this throw state error is throwing back this exception to the main function. But because of that, you don't have any exception. You don't have any like some kind of apps unguarded, as I said, like this one. You don't have any runs unguarded. This is not handling that. That's why, in order to use them, you can do run zone, this one, run zone guarded, run zone guarded. So error tries. So put your code here. Is this one? Is that all? Let's see. So some volume and not. Maybe this one. So let's print this one. Zone. Let's see. As you see, because of that, we have some kind of run zone guarded. Yeah, that checks whether any exception that was thrown to the main, it will handle that. That is why some kind of try catches. There is a specific code that try catch can handle that. That is why you can use run zone guarded. Because of the run zone guarded, you can use that. So when we check this one after specific duration of time, catch will not handle this throw, the state error, this exception. It will throw your exception right to the main, and because of that, we have runs unguarded. That's runs unguarded thing. We will this kind of function will handle your error. So I think, yeah, I explained you as possible as I could. So you can use the logger here, logger log level error message error some kind of thing. You can do like this one. So we wrote about all Flutter errors, specific things. Also we should create our dependencies, create dependencies. We'll pass the logger, and we have to run our application here. And because of that, we have a root context here. We'll do a root context. It will run our root context. We will pass our dependencies to this root context. Final dependency contain dependencies. Required dependencies. And also in order to pass all this dependency container, we could use the provider package Flutter. But we don't have to use them right now. It's very good. It's very good to use. I don't have any, I would say, any bad things about this provider. It's a very good thing to use. You can use that. You can like provider as a provider. You can use like this one on top of this here, like provider, create our dependency, and these dependencies like provider. You could do like provider dot value, some kind of thing, and it should have some. I don't remember. Just check. Provider dot value. Like this one, yeah. Well, value will be your dependency container, and child, it's the material context. This one. But because of that, we don't have any. We will not use this one. You can do exactly the same if you want. Just grab the package if you want. But because of that, we have Flutter BLoC, Flutter multi-provider, or just multi-provider, multi-BLoC provider. These kind of things we will not use. That is why instead of them, we can create our own dependency scope. You may ask, what is dependency scope? This code will pass pass this dependency container to the whole widget tree. For example, whenever you want to use, you will do context.read, like context.read, and that's all. You can take your dependencies from here. If you just saw any application that uses provider, just write down in your YouTube, just check, just watch a video about provider, and you can use how you can use this provider. It will be it's very easy to use. That is why instead of that, provider works exactly as same as like provider under the hood uses inherited widget, inherited notifier, some kind of things like change notifier, if you may hear. That is why we will create dependencies scope there, and we will call that inherited. It's inherited widget dependency scope. It should not. So there's a lot of questions that you may ask. Dependency inherited widget is kind of like widgets that passes your anything that you have down to the widget tree. So that is why just stop your application, stop your video, and just check what I'm doing here. Okay, so final dependency container, just dependencies, this required, it's not required, child is which is required, so we will do like this one. Required super.child, and required these dependencies. That's enough. So there is two things which is necessary. Also, you know what? This listen is not necessary, I guess. That's all. That's all you can do. Just stop your video, just write down all of these things. There is two things in order to as you may seen you have seen my other videos in my YouTube channel. I've told about context. Which word is this? Build context help us to know what specific position we are in a widget tree. It helps us like work with the like a root of context, root of state, some kind of places. There is where there's a context, and it finds the nearest dependency container, inherited widget. Excuse me. It finds the nearest dependency container, dependency scope, which is inherited widget, and if it finds, it returns dependencies here. This static method. That is why whenever in your application, when you do dependency container dot of context, it will go like there is a widgets, yeah, like widgets, and you stop somewhere and you want to use your dependency container, it will go upside, like from your widget tree to in your widget tree, and finds the nearest one dependency scope. That is why this dependency scope you can use anywhere in your widgets. For example, there is your application, which is main application, which be, but I just want you to know that dependency scope should be used only once, and it should be used for whole application. But if you want to use dependency container, like exactly same thing, which is inherited widget, another class maybe, you can use them anywhere in your application, anywhere in widgets that you want. That's what dependency scope. It's some kind of place, some kind of, I would say, place that holds your dependency container and provides this one for your whole application. This provides this dependency container for your whole application. So that is why instead of doing that, instead of using provider, we will use this dependency scope. Provider works exactly the same as our dependency scope. As we passed our dependency container, we'll use dependency container here and our material context here. That's all. It is the reason that material context will be so our dependency will be visible, because of that we are using our dependencies up from our material. So this one. There's our root context needs our dependencies. Dependent will pass the dependencies, and that's all. So let's you know what it. Let's start our application then. There's a main void our main file, Dart file, app runner. Okay, run. Yes, is there a logger here? So where is the logger? We don't have to use logger here. Excuse me for some bad code here. So our logger should not be visible, like from this only run function should be visible. So we create our logger inside run application. So what else should we do? There's only one thing remains to do. Or maybe that's enough. Okay, then that's. For example, in your application, let me explain. For example, something happens while you're creating your dependencies. Some database maybe fail, maybe something happens, and when your application fails, you have to run something another application. Yeah, for example, when you want to run some another thing, some another widget which is, I would say, notifies the user that application was not run, and just try later maybe some kind of things. So for example, dependencies didn't work, I would say. So you can use like fire, what is that, error dot, what does it do? So it's the thing that throws your catching things. For example, you or maybe it's not necessary, I guess, because in your application, to do application. But look, what does it do, you may ask? For example, error throw stack trace, with stack trace, it means that when you some kind of dependency throws error, yeah, through error, and your run application didn't work, this catch one, it will catch, but it will not notify our runs on guarded. So we can use this one, we can use our Firebase Crystalletics. If you don't do that, we will not know what happened in our application. That is why whenever in your application you are using catch, you have to use rethrows or maybe error throw with stack trace. It's this helper that throws the application back, I would say. Throw your errors back. That is why. For example, here you can run another application, scaffold maybe, yeah, with the bari, maybe some kind of application which is, for example, let me show you, failed application maybe, yeah, failed application, failed app context, maybe material context, failed app, just failed app widget, set full material, failed app, material app, home, scaffold, body, center, app was not run, was not started maybe. You can use this one. So if your app doesn't start, we'll catch this catch error. This the catch statement will catch your application error, applications error, and run another app, and also it will throw stack trace. This will throw your error back to the run zone guarded. So let's start our application. See what happens. So we have all the scaffold here, and we will start creating our to-do. Excuse me. Excuse me that it's taking a lot of time. So while it's compiling, let me show. Let's create our screen to do, all of the screens that shows our to dos. So there is our feature called to dos. We will create a block here. We'll create data, and we'll create widgets here. As you may have seen a lot of videos in YouTube that people use like feature clean architecture. So you see that, yeah, our application ran and it doesn't show anything because of this scaffold. And when we create our to-dos, we configure them. So that time we will do something. So what should we do here? So first of all, I was talking about clean architecture, and you may have seen a lot of people out there in YouTube that creating like some kind of use cases, repositories, like data, the inside data sources. Also, there is a interfaces. What was that? Not interface. There's like data has its own repository. There's a domain layer which has its own repository. It has also a use case. It has a lot of boilerplate. It has a lot of unnecessary code, which is. That is why I'm going to show you a simple application, simple clean architecture, which you can use anywhere in your application. Doesn't matter which it is, big application or not. You can use the same logic, you can use the same folders, files that I'm writing. Now I've seen that a lot of people using presentation layer instead of widgets layer, because presentation is not. If you are writing in Kotlin, maybe if you are writing in Java or some kind of places which you can call the presentation, but it's not presentation, it's widgets layer, because I told in previous videos that the widgets, it's just immutable, some kind of objects that represent the configuration of applications, not the view. You can call them screens, maybe you can call them some kind of things, but you don't have to. You are not allowed to call them presentation. Presentation, it's not. So you're not presenting anything. You have a widgets. You're configuring your widgets, and there is some kind of trees in the Flutter, like widget tree, element tree, or in the object tree. Widgets, as I said, is just a configuration of your application, of your screen, of your everything that you can show. There is the main tree that which calls element tree. Element tree like holds, keeps, and configures all of your application. It shows where the specific widget in widget tree. It shows like you can. It's all of the concept is about build context, elements, some kind of thing. But the element and elements and the build context, both of them are the same thing. So that is why elements, I would say, some kind of widget tree, some kind of trees that handles with state of your application, but widgets, some kind of tree, widget tree, some kind of tree that that shows the configuration of application of your screens, I would say. So that is why we will create to-dos configuration widget, and also we will create to-dos widget. It's just a widget. As I told about configuration, like widgets, it's a configuration of your application. It doesn't relates to that one. I was talking about widget tree and element tree. Just widgets, the configuration of your app. But this one that I created, this configuration widget, it contains another thing like configuration, configuring your BLoC, some kind of dependencies to pass them down to the widget tree. That is why. Let's introduce configuration widget, scaffold. Just, do you know what? Just watch my previous videos if you want, or if you want to just see the main Flutter documentation about widgets. Check other developers, good developers that tell about widgets, and I will put the link down below to this description. That's why we have a scaffold, a bar. So we don't have any app bar. Okay, but this is better in this example. Okay. Your to-do app, style, text style, font size 24. It's a bold, font weight, bold. Let it be here for a while. Okay. You don't have to write here. You have a to-dos application which is part of. There's some kind of keywords that exist in Flutter in Dart. So this part of it means that we are going to make our to-dos widget, this file, part of this file. So we'll write to-dos. We are telling that this file that we are creating, it's like delegates. If you have seen in other like iOS development, Swift development, you can create delegates. It's like exactly same thing like this one, but in Flutter there's no any delegates existed. So you can use part of, which means that our class, our file is the part of our configuration widget. In order to include that, we use like part to-dos widget, and that is why you can use a lot of this one, a lot of to-dos, a lot of parts, a lot of widgets that can be part of this one. So we'll create stateless, stateful, doesn't matter, stateful to-dos widget, and we will put our code here, and that's all. So it can be private. It can be private because we are passing our to-dos widget here. So because of that, we said that this is the part of this file. So if you remove this one, it will throw error. So that is why we'll go and create our BLoC here. So to-dos BLoC. Do you know what? There's a it's not good. Okay. To-dos BLoC, to-dos event, to-dos event, so to-dos state. So we'll write sealed class. Sealed class is a class that can be helpful with using switches. I will show you later. Sealed class, to-dos state. Okay, so we can do like this one. I'm showing you without creating states, event, without using freeze package. So in our state we have const to-dos state, our initial state. Okay, we have initial state. We have to-dos factory, to-dos state, our in progress state. You can not write the state, yeah, it's better. Initial state, progress state, const factory, to-dos state, error state, state completed. So in order to create classes, we have to create states for them. That is why here in states we have to create classes which calls to those initial state, extends to those state. It should have constructor in it. So there's a code generation I had from Gemini, I guess, from Android Studio. It comes from Android Studio. That's why it's helping me quickly write necessary code here. So as we create our state for our BLoC, so it represents our initial state in progress, which is loading from repositories, its error state into this complete state. And also we will create our events here. Seal class, as I said, seal class is a class that is very helpful, for creating, like for using for switch cases. And I said that I will show you later. I will show you that. To-do's event. So it should have load, I guess. Comes to-do's event, comes factory, to-do's event, load, to-do's load event. Okay, so it will help. No. Up. Final class to this event, to this load event. It should be, I guess, private one. So we create our event and create our state. So what else we have? So it loads. It also it removes. Okay, we will do const factory this event, delete event, delete. So this one. Okay, the only one thing that we have to do, we have create our model here. Let's call it to do creation, maybe to do creation. To this. Where should we put our model? There is a conception which says that if you have any model to use, you have to use that model right inside that feature. For example, we have to do model. Yeah, it's a class that represents it's all about OOP, for example. Yeah, you have some class and you will work with that class. And because of that, we create our to-do inside to-do creation. You can put that model right inside to-do creation. We can use that. But because of that, we are showing our main screen is right here, to-do. We can create our to-dos, like our models right inside to-dos. This doesn't matter. That is why there's two folders which works with exactly the same model. This is why you can create them right inside one of them. So we can create the to-do clear class to-do. and it has, I don't know, final string to do, final string ID, and that's all. So required this to do, and ID should be, I guess, some kind of thing. We don't have UID here, so you can use Flutter UUID. So we can do, I guess, like this one. So string temp ID, ID, temp ID, or this one. Or you can do that without the temp ID. I will just let it be here. So we have a block, state, we have states, we have to-dos, and while we refresh our screen, while we refresh our screen, we have to see our all to-dos here. That is what you can do. In this completed state, you can write, we are waiting for our to-dos. Whenever state is completed, so whenever it's completed, you can see all of your, so it's throwing an error. It's saying that you can use that because of that this class doesn't have any final to-dos. That is why we have to create our to-dos exactly same like this one. Like you did like this one, you have to add in your constructor too. So that's all. So that is why we have BLoC, to-dos BLoC extends BLoC. So we have to-dos event and to-dos state. And that's all. That's all thing that you have. Super constructor. So right now we have to get our to-dos from somewhere. It can be from a local database. It can be from remote database, doesn't matter. Whenever you want to get this one, you have to use some kind of data repository or maybe data source which is connected to each other. And I've seen a lot of projects that they create a domain layer which has its own repository, and they create a data layer which has its own repository. It's a lot of code there. Instead of that, you can do like simple like this one. And all of this conception that I'm doing, I will put all of good developers links down below in this description of this video, and you can check it out, check them all out if you want. So to-dos repository, abstract interface class, and I will not tell about what does abstract do, what does the interface do. You have to go to the DARS documentation and check it out, check them all, what they do there. So to-dos repository, but remember, if your repository's interface, do not forget to put this like interface. It represents that it's to-do repository's interface. It will show our developers that you're using interface there. So our interface should return the list of to-dos. Okay, and we'll create the implementation for this repository, for this interface. So it's the repository is the repository. So remember that, for example, as I said, there's only one repository that works with internet connection, that works with other data sources. And if there is internet connection exists, it will just make request to the API. If there is no internet connection, it will get from local storage, I would say. That is why, because of that, we don't have any server right now. We will use all local storage, local database, Drift, as I said. We will do some kind of things. So we will create data source to this data source. It will be interface tool. I'll show you why. So to this data source into data source, because it's interface. And the class to this data source remote implementation. Okay. Introduce data source. And you create the final class to use local data source, local implementation, implements a data source. So look, why we created these two classes, because if you have internet connection, this kind of class will work. If you don't have any internet connection, this local implementation will work. Why? For example, we will copy this interface and go to our repository implementation, and we will say that. So we have to do remote data source we have, and we have exactly same interface but to do local data source. So that is why. It means that when we configure this to the repository, we will pass the specific implementation for them. For example, you have a lot of local implementations of the specific interface, and you can use one of them here. Do not forget to pass right implementation, because if you pass the local data source, local implementation of that interface to the remote data source, you will know what happens. You know what happens. So that is why. So happens a lot of bad code. Instead of requesting to the server, you will get from local data source like this one. So this kind of thing should be private. Let's see whether our it's helping to us. So we are creating our own data source here, data sources. And in order to check whether there's internet connection or not, we can do something like this. Let's just give me a couple of minutes. I will grab the code. So we'll go to let's grab this. This kind of package helps us to check whether there is internet connection or not. We'll go to the common. We'll create internet connection checker, internet connection checker helper service. Maybe you can call them. Just we'll click the checker class. Internet connection checker future bool has access to internet connection. That's all. We'll copy the internet connection. And we are waiting for internet connection checker here. So we'll check here that whether we have internet connection or not. If we have access to the internet, we will return our to-do remove data source. Okay, let's go and create our function inside our data source here. We will not write any code inside remote implementation because we don't have any server right now. But because of that, we have app databases. We will create app database, local database. We'll use that. But for now, let's return just a simple to do. So we have to-dos. It will return to-dos, else return local one. So we have to add our repository right inside BLoC. Okay, final a BLoC here, and we will do okay. So super we have here, we have internet repository. So also we have, in order, if you want to test your application in the future, if you want to test your BLoC in the future, it is very helpful if you do some kind of test state. For example, you may pass the test state, initial state. But if there's no initial state, you can use your to-do state initial one. Okay, so there's a conception, and BLoC handles it very good, very, I would say, magnificent. It's very awesome to use that, especially this concept. It calls pub/sub pattern. It calls pub/sub pattern. There's a lot of patterns like observer, as I mentioned in my previous videos in this YouTube channel. That there's a lot of conception, a lot of principles, but the main principle that you can create very good application, maintainable, like scalable application. You can use that pub/sub pattern. Pub/sub pattern, it's like some kind of pattern that works, that handles concurrency, race condition, like some kind of things. For example, concurrency, it means that all of your state, all of your application should run concurrently. And also there is a another conception which pops up pattern do. For example, race condition. There is a race condition which is very bad. For example, you clicked your button twice, and all of that state, all of that logic is working in the same time, and you don't know what happens in a specific another duration, another time, another moment. For example, you click that button. This button makes request to the server, and because of that, you click that one twice. First logic, when it's still making request to the server, the second one ends before the first one, and it will be like not clear what's happening. For example, the state is already completed, but the second one, which is still in progress, suddenly like start to like be in a progress, or maybe it will throw an error. Something happened, and because of that, the first one, which is already finished, which is already everything is good, you suddenly see that there's a state error because of the second tap that you did. That is why there is a calls concurrency, or maybe there is a state. In order to remove that concurrency and race condition, you have to use sequential as I said, BLoC concurrency. So you have to use sequential one, not concurrent, not restartable, not droppable, but sequential one. But it depends on circumstances and situations, what kind of code you're writing. For example, there's a moment that you can use droppable, or maybe not concurrent, droppable, restartable, something like that. But sequential is one of them necessary. That is why let's go and add this one. So when we added then we can grab our to-dos event, put on and say event init. And as I said, the sealed classes will help us to work with switch cases, like this one, switch event. You see that it's notifying us that you're not added specific cases. For example, you're missing some cases, it's saying. But if we remove the sealed class from here, look, so it's helping. You see that there is a to-dos event. There is a written like to-dos event, but it shouldn't be like this one. To-dos event. We are not adding the same event like twice. It will not be. I guess it's Stack Overflow. It will be Stack Overflow. There's this exception. For example, that is why if we add our sealed class, it will show that you are that you have to add your. Why it's not working? It's not working. Then give me a minute. So why? There is no any showing there. It's not showing. To this event, to this load event. Interesting. Aha, I forgot that it should be the part of it should be part of the block, part of the block, to this block, to the block. This is why we will remove that part to this event. Also you have to do the same thing here. Part of this block. It should be the part of this block. And it will add this state. So it will add our here. That's all. You see, it's showing us to do load event, to do delete event. If we remove the seal class from here, just class, you can see that no switching will not help us to this event, just only to this event. That is why seal class is necessary for switch casing, some kind of. So look, what I'm gonna do, what I will do. So as I said previously, you can use sequential transformers like concurrency, sequential. This concurrency package, you can use them, and you can use a consequential. That is why you can use them right directly in a BLoC event, like transformer sequential. But you can use it. It's good. It's very good. If you want to use them, do them right inside here. But there is another thing that you can do. Go to the initialization app runner, and before doing all of that, you can use BLoC transformer sequential. It says that even if you're not using this transformer here, for example, you can do droppable. This transformer will be used only for to this event. Droppable transformer will be only for to this block. But if you remove that by default, all of this BLoC transformers will be sequential. Yeah, you can do that. So do you know what? Let's create BLoC observer. Or directly we have to use like this. We can use BLoC observer. And I have a BLoC observer which is already prepared. You can just copy that and paste them. BLoC observer, which takes the logger. Okay. Let's delete this one. BLoC server. So what we have? So I will put the link for this project, and you can come inside and just copy this all. There's a lot of stuff to do, that is why I just copied them all. So BLoC observer manager. We'll pass the logger, that's all. It will help us what kind of BLoC is working, what kind of transformer is working, what kind of event or state is right now. Through this observer we can handle what is going on in our application. So that is why I remember that because of that we have, even if we have two events, we don't have to do like on another event like to this event here. We don't have to do that. That is why it's because of concurrency, it's because of race condition. That is why you have to use. You have to do like this one. Until this event finished, this one will not start, okay? So let's start creating our functions for them. So that's all. We'll write our logic here. So delete. Yeah, delete. We have to write right inside here, yeah? Because we have this close icons. So what we can do something like this one. We'll write try catch error stack trace. So in progress, we'll start progress. We'll do like this one and complete this one. It's doing instead of me. So it will error, and we have to throw our error. So what should we do? So first of all, we have to emit that we have to say to our BLoC that we are in progress. That our progress, we are loading our to-dos. From where it doesn't care. Like, do you see that to-do BLoC doesn't care from where it's coming? To-dos, where they are coming from, doesn't matter for BLoC. If you go to the repository has its own implementation that we will configure later, and it will return, if there is internet connection, it will return from remote data source, like from database, local data source. If it has internet, there is no internet connection, it will return the local one. That is why BLoC doesn't know where it will get data from. So that is why if there is any error happens, we will say to the BLoC that it happened, like there's some kind of error happened, and we will throw our exception back to this like main, to that app runner runs on Guarded. Now it goes to the, I guess it goes to the BLoC observer in order, and yeah, because something happened, that is why I removed the super error here. Yeah, avoid calling super on it to prevent propagation. If you want to propagate your error to another function which is coming, which is calling, you can remove this one. So let's go and create our to-dos widget, and we will create to-do widget. So it has string, it has ID, and it has final pool is done. Yeah, it's done. Is done. Let's go create to JSON from JSON for this one. So map string object to JSON, and then factory from JSON. That's all. Should I call this one temp ID? Okay, let it be here like this one, and it will set the ID. Okay, to JSON. It's better to do that. But there's a documentation. It says if you want to write clean code in Dart, you have to put the factories, all constructors before, after constructor like this one, and all of the string, all of the parameters of the class, which is the string boolean, they have to be after, like after constructors and factories. But let it be here. Okay, we'll do what they say. ID is done. So done is done. To do like this. Okay, so we have a widget, stateless widget, to-dos widget, scaffold for a while. It will be decorated box, decoration. Decoration child is maybe padding. Edge sets geometry all 10. Children, so it will have a checkbox. It will have size box. It will have a text. So we will pass our to-do here. To do, what should we do here? And it should be extended one. It should be 10. Icon button. Also it doesn't matter. We don't have to use it. Icon button. Icon to dot close. Value to do that is done. So what you can do? What else you can do? You can do. So, a new task. I guess to this is just enough for creation one. Or to do. Okay, let's run our application then. We have to add out this configuration to the material context on there. It's here. So the UI doesn't matter, it's only for learning. The purpose of this project is just for learning architecture, how to create them properly. That is why let's go and create the databases. If you don't mind, let's go and create database. Where is the database? So database, will go inside the database and create app database, which we will use Drift. So that is why let's commit this one first of all. Added to-dos feature, and only one thing that remains to do is writing. So we'll create an app database. So let's go and create the Drift database thing. App databases extends. Because of that, we will generate this one. We have to write as it says in documentation. That is why there is a documentation which says that the ways that you can create a database like this one. So you can copy this. So you can copy them, you can add. So that is why we can create to-dos database, you can call them. So you can do, what else you can do? So you can do remove this one, schema version. You can create here tables, you can create here database helpers. So what else you can do? Remove this one for a while. So you can, what else you can do? Database. Custom. Drift database. This one and this one. So name is to those native drift native options, and web. For web you can use drift web options. So you can do something like this one, and also you can write here parse. Is there any web? If you need web support. I need this one. So let's run our build runner. So we don't have any tables now, right now. There is one. Let's go and create the table. And there is a documentation which says you can create tables very easier. Let's copy this one. Put here this, here drift. It's not trains. This is text column, integer. We don't need this one. Text. You can do null, but it's not nullable. That is why. That's all. Title to do. Don't need any lengths here. And what else we have here? To do's. We have boolean is done. So we create boolean column, bool column is done. Named is done. Don't need this one. Or you need this one. Okay. Just the time column created at. It's better. Let's go and create the file created string. Add. So. Okay, let's create that time. We don't have any. We'll see. I guess that we don't need this 2JSON method. It's not necessary to us, I guess. So, required this. Created that. So it created a database. That is why, in order to not add this one to the git ignore to git, we have to go copy this one, put here, and instead of that, just write app database.g dart. Or maybe generated is enough. Or maybe we have to create. Oh, that's all. So it's not that's inside the generated one. That is why we have our app database right now. So we can create our app database. We can go to our app runner. We can create our dependencies here. So because of that, our dependency needs, our whole application needs app database. We can create it here. Require this app database. So it will throw an error. Required, or maybe even if you don't have any application database creation before that, you can create your app database right here. App database data. So is it right to create like this one? Let me check it out real quick. Yeah, it's correct way to create a database. So as we create our app database, we can go and write the logic for database helpers. So database to do database helper. So we can create database helper to do database helper, which will take app database to do database helper. This database. If you want to pass a logger in order to check, you can do this one. Oh, future list of to-dos. Okay, so final database to-dos app database, select app database to-dos table, and get them all, I guess. It will give us to-dos table data. That is why we have to do something like this one. The return database map L. So what's happening? Is this something happening here? Database map L to do from to list to do. That's all. So table data to do temp ID ID. The table data is done and table created at. So wait a minute, it's not nullable. That's all. And we wrote what to do's, forgetting to do's, so we can write to do future bool add to do await database into app database, it was table insert to do, is it to do data model table data like this one, yeah. So it returns true. So also we have to in future we'll write logic of removing delete to do. I guess you can pass the ID here, but the string ID, yes. Run or go. I guess it was like this one, yeah? Just check me this. Let me check this real quick. So app database doesn't have any future. It should have future, no? Delete to do's. Yeah, like this one. So well, ID equals to our ID. So So. I guess that the to-do creation is not necessary here, because look, we have the same thing here, right here, lies right inside one screen. That is why I don't have to create the creation feature here. So what else should we do? So we have, as I said, dependency container holds all of the necessary dependencies, and necessary dependencies are those dependencies which you can use for all application, for all your application. It doesn't matter whether it's BLoC, they are BLoC, maybe they are the repositories. That is why most of the people, most of the good developers suggest us to use only repositories there. You can use controllers like BLoCs there, but it's better to use repositories, maybe some kind of like classes that should be used there. That is why you can write to-dos repository, and you can create a function here that calls to-do repository, which creates local to-dos data source, to-dos local data source, to-dos local implementation. And our to-dos local data source should have app database. Yeah. But, I guess it doesn't have a database. It should have final what was the name? To-dos database helper should have. To-dos database helper. To-dos database local implementation. This one. So that's all. So we will go to the composition root. We'll create here final to-dos database helper. To-dos database helper. Database helper. We have to pass required app database. Also we have to pass the logger here. So to-dos database. So we have to create a remote database, and also then we will return to-dos repository implementation. To-dos repository implementation. What was the implementation of that? To-dos repository implementation. It's much more clear to understand. So also we have internet connection here. So we can create internet connection checker. Internet connection checker here, and you can pass the internet connection required. Internet connection checker. So local data source, remote data source. You can pass all necessary things, and you can create your final to-dos repository. create to repository is much more better to understand. So as we created our to-dos repository, we will pass that to-dos repository, and that's all. Our dependency container is created, all necessary dependencies in it, so we can use the same dependency for whole application through this dependency container. And you may ask, how can I use? Because of that, we created dependency scope. Dependency scope is the scope that pass our dependency container down to the widget tree through this dependency scope, through the material context that we created here, material app. So here, root context creates dependency scope, and so on. Even you can to not create root context, you can create only material context right here. So you can create, you can wrap dependency scope app from material app, and you don't need root context anymore, I guess. Let's do this one. Yeah, final dependency container. So we will do something like this one. And you know what? Because of that, we are using this material context. The state may be changed. No. The state will not be changed. That is why dependency scope, dependency container. You can use this one. And then because of that, we are using only material context. We don't need root context anymore. If it's necessary, yes, it's necessary, because if you are doing some configuration with your, it will be necessary then with your widgets. With your, for example, you are loading for desktops, or maybe you are loading for someone else, then it will be necessary. But right now it's not necessary. So let's start our application. Let's see what happens. So let's go commit that. Added all necessary dependencies and configured to do app database. So let's see what's happened. What happens? Everything is good. Everything is running. So here in the configuration, let's create our BLoC here. Have a BLoC. Should we create BLoC here? It will be very not clear. That is why it's better to get all of the widgets that we have here. I just showed you can do some like part of some kind of things, but it's better to just not create this one here. Or just grab all of this configuration widget. Yeah. Switch it here, from here, put here. Let me just copy this one. I guess this one is not necessary anymore, this one. So to-dos widget and to-do widget. To-do widget is just a simple widget to do. So we can create our BLoC here then. What can we do? Late final to-dos BLoC. So to-dos BLoC in its state. We'll grab our dependencies scope dependencies scope of context, so that we can get them. Then to do BLoC, we can create our BLoC, be it like this one. Oh, right there. So to-dos BLoC, to-dos BLoC dependencies scope to the repository. So if you want to use logger here, you can just pass the logger. Just use the logger here, log level count of coming to-dos. So it's about to-dos length. So somehow like this one you can use logger which is doesn't show any logs in the release mode. Just check them if you want. Because of this it will not show anything. Create logger. When we create a logger, development filter will. Oh, if when it's car release mode, it should be no. So development filter, like this one. If it's release mode, no filter should be there. No log should be there. So to-dos filter also takes logger, dependency scope, logger. That is why I said to you, through this dependency scope you can get your own dependencies. So that is why when we are going outside, we have to close our BLoC. For example, just imagine that specific screen will be used for entire application. For example, you have a lot of buttons, a lot of screens. You go inside that screen, inside another screen, and suddenly there you will see a button that creates to do right from that screen. Just imagine that you're in a 10 screen. The screen of number 10, for example, yeah, you went inside the screens and you suddenly see there is a button that creates to do there. You click on that button, creation button, you will open this one. And when you open that one, you will create a BLoC. And when you go back from that screen, you have to close this one. That is why in this pause method of that stateful widget, of that state, I closed it to this BLoC. So that is why, in order, if you want to use the specific BLoC that you created, so you have to do this one. BLoC provider, BLoC builder, context, state, return your custom scroll view, to-dos BLoC, to-dos state, and this in this moment, in this particular place, you can use your BLoC here, to-dos BLoC. So, as I said previously, the sealed class in a state, where the sealed class helps us to use switch cases. That is why when you write switch cases here, state, if it's initial state, you don't have to show anything. If it's, or you can say that anything, initializing, or maybe sliver, fill remaining, center, text, me, like this one. If it's progress and error state, you have to use the same logic. For example, you can do something like this one, but instead of text, you can use circular progress indicator. If it's error state, you can say that it's like text button maybe, or elevated button. You can say that text error state refresh maybe. And you can do here your logic sliver, list, builder, text index, return to do widget, to do state to those index. So look, I just want to show you that this state doesn't, in the state in this particular place doesn't have any to do's. Because of that, you're checking that is it completed state. If it's completed state understands that the to do's will be here, but that is why to do's is showing here. But because of that, state is not completed yet. It's error state that we wrote in our state that our to-dos will be only in site completed state. That is why you can't use to-dos variable in error state, or maybe in progress state. You can use them, but because of that, you are not writing any to-dos here like this one. You can't get them from this state, from to-dos error state, because you are inside here, or inside here, or inside here. Only you can get those to-dos from here. Only the one way that you can get them from here. So when you're initializing that, we have to say that we want to load them all. Like to-dos event load. Get all of this to-dos from database. Okay. Well, let's check. Nothing happened. Unimplemented error. So I understood that. You see that, yeah? Something happens and this error state. So we will go to our repository and we'll take a look what's happening here. Okay, because of that, does the internet connection exist? I showed you this kind of implementation. Because of that, you have to do this. But because of that, we are working only locally. You can comment it for now, but just let it be here. Let him be here. So another one. So it's another item count state, another error which relates to our widgets. So we have to say that we have specific range. This separated, I guess you already know what is separated builder. It separates all widgets in list. So everything is working. Everything is working, and you can also add another widget, refresh indicator. Refresh, on refresh, what kind of, yeah, on refresh. You can grab it and put this next it as well. Everything's working. So, so what else you can do? We can imitate that our database is loading for a while in order to just see whether our application is working or not. So this way I just do like this one, await, future delete, duration, seconds to, oh, sorry, that's good. Just check that. Yep, everything is working. So the only one thing that you can do is saving widget. That is why let's create our text editing controller to do text controller. We have to dispose it when our screen closes. Then especially here, this screen will not be closed anytime, but you have to do that. It's the main principle that you have to close all controllers or the streams before going outside from the screen. So that is why we have a UI here. So add your task. Go here and write inside here. You can write sliver to box adapter. There's a row. And we are doing that just for learning purpose. That is why we don't have to make it beautiful like this one. But it's just easy. It takes about 10 minutes or 15 minutes to do. Just if you want, just do that. What was that? Okay. We have to go to the BLoC event, and also we have to create here factory to do's event, create to do. So it takes what text? It takes string. Yeah, exactly. It takes string. So look help. To do this to do. That's all. So this switch is throwing error because it's saying that you didn't add all of your events. That is why it's throwing error. Just repeat after me. If you didn't understand, ask me in the description. I will help you. I will try to explain you what's happening there. But I guess that's everything you see. It's very clear to understand. Just creating BLoC. That is why before coming to this video, you have to understand what's going on there. What's going on? What is BLoC? What is all of the stuff? And you will understand that you have to just do what I'm doing right now. So create BLoC. So if it's text controller, to do controller text stream is empty. Turn text clear. That's good. Let's go to the BLoC. First of all, let's go to the repository and create future bool. Create the thing to do. The reason why I write final string to do in this kind of parameters, I will explain later. Just let's create the let to do final. The reason, I will explain you what is the reason. Just wait a little bit. So we will do the same thing here. So to the data sources, we go to the data sources. It will return future false for now, future value false. It also returns future because we don't have any remote data source for now. That is why we can use, we can imitate them. So to do helper, create, what is that? Insert, delete, add to do. Created. Let's name it created. That's better. Created. Go. Let's say string to do. Okay. It's good. It's good. It's good. Good. So it will remove to do. Delete to do. Ready. That's good. Now we will go to the repository. All the repositories logic are the same, like create to do, but first of all final to do. We have this. We have to send it. If there's internet connection, delete to do. Delete to do. So I guess. So we will go to this BLoC and we check that if our state is not to this completed, we will return our code. So we will say that our state should be completed. Let's say. What's happened? It's completed. And we say that final to do's state as to do's completed state. We will take it to the lists from here. List of. Remember that you have to use list of over the from. Why? Because when you write from, it doesn't understand what kind of list it is. That is why it returns list dynamic. But when you do list of, it returns to do, list of to do's. So final new to do event to do is done false, created, take time, now, and final create to do. If created to do is successfully created, we have to add that created to do inside to do's and emit our state as completed with new state of to do's. So it takes the same thing, the same logic in the deletion. So let's restart. So we have to do some kind of logic here. What kind of logic? Should be padding, sliver, padding, sliver. It's better, or maybe not. All stuff. So it's normal. Add some kind of decoration. Decoration hint. What is that hint? What was that? Input decoration. Yeah? Hint text. Add new task. Add new task. Okay, so add new task. Then we have to put some kind of sliver to post those, try size post that down here. Then click this one, nothing happens. So when we click this one, some new task happens. It added to the local database also. That is why when we restart our application, let's see. So it's working. So we added that thing inside of it. That is why if we open our DevTools in browser, we can see that there is a drift. So there is a drift. It opens to this table. There is our that we added. For example, need to wash dishes. You can see it's adding right now. Need to wash dishes. That is why when you just restart your application, you can see that it's working very well. That's why just let's just simply make the UI better. Yeah. So there is a decoration box, border dot all color gray. There's padding inside of this one, and also we have to add padding from outside. This one we have to add border side, border radius to circular type. That's good. It's already good. And we go to the app bar and we set it under elevation. Okay, this one. So elevation, scroll, elevation, also 0. Why? Changing the color. Whatever. So we have to add a logic to removing them. was better to create inherited widget and pass that block to with the inherited widget. But since we don't have any, for example, I want you to understand what's going on here. If I create another dependency scope, another inherited widget here for dependencies for this to this block, yeah, you can use multi-block provider, block provider, and use them through the context. But I want to understand what's going on here. That is why I need you to keep it simple. That is why I just pass the block here. Okay, because there's a newbies, a lot of scratchers, or maybe a lot of beginners, when they see this, what's going on here, they may probably will not understand what's going on here. That is why I just add to this event, delete. So to this block, this, well, we will pass the block too. So when we click to delete, we have to say that our state should be completed, and we have to delete this one. So that is why in order to delete that, we have to send our to-do, delete to-do, string, not string, to-do itself, to-do to the event. We have to send them to the event. So you may ask that why I'm writing final here, or maybe I was talking about in this data source, for example, there's people that write final. It's because of that a lot of people, if I don't write final, a lot of people change the string ID to something else. They can change them. That is why if I put final here, it won't let us to change them. So delete event to do ID. So if delete to do is true, to do's remove that, remove to do's remove where, then save that. That's all. Let's check it. Nothing left, I guess. Nothing left, I guess. Everything is working pretty good. Let's delete this one, refresh. It's simulating that like we are getting our data from somewhere, but it's local storage. That is why it was the code that I wanted to show you how to imitate date. That is why it's working pretty fast. So we have to do like we finished our. There's something else was there. What I was talking about, the first thing that you can do, let's go to our here. If state is to do completed state, we can write down our your remaining to-dos here. Like your remaining to-dos here, how we can do that better. State. So you can use only completed state here, but for other ones you can do like this one, 0. These so to-dos, can I get to-dos? No, exactly no. So these as to-dos. No, what am I doing? We can do like this one. No, state this links. State this where L точка is done, is not done. Links. So you can use this one here. Sliver to box adapter text. So your remaining to-dos, your remaining to-dos state get remaining to-dos. So sliver to box adapter as well. Take a look. Okay. So what you can do, what else you can do, I would say. So you can add another boolean future, bool, and not update, maybe update to do. Okay, update to do. So it's better, I guess. So we create update to do. We'll do the same thing here, but it will be another update to do. So we will go to our helper, create a do, we'll update to do, welcome to do. app database update to-dos. So where element ID equals to-do ID. So let's check it out. I don't remember how to update that. Yeah, that's all. To this companion. Okay. Alright. To do table data. So, is that all? I guess that's all. It simulates that whether we are updating or not. It's just a simulation of that. So in this code, we will call our update to do. We will update it. So we will have an event which calls cons factory to do event, not update, but it will be check to the, or done to the final to do. So we will create final to do. And here in the switch we will add our event in order to update, in order to check whether we completed our to-do. To-do done. To-do's done even, no? Okay, so we will do something like this one. And we will say that copy of this, exactly, we have to create copy of this to our event. So to do. So there is a conception in programming pattern which calls prototype. Prototype also means like copying the object, the mutable object, with new values. For example, you have an object and you don't want to change them. Yeah, you want to change them, but you don't want to change the real instance. That is why you have to copy that from that copied instance, copied to do. For example, we have. You can just simulate. You can change data, but the real instance will never change. That is why copy is very good pattern, like prototype. It's called prototype, but there is only one thing. For example, when you're copying thing, you can write here to do, maybe, yeah. You can write to do. For example, if your application, if your model is nullable, just let's write it. For example, final, you have final time updated it, but it's nullable. But when you're copying this one, you don't want to other people, when you're copying them, you don't want them to, like, so when they send updated add, which is nullable here, right? Which is nullable here. Updated it. Excuse me here. This updated it. Okay. For example, you don't want other people to use updated add. For example, when you do updated add and this updated add, when you send nullable from outside here, nullable when you want to send nullable here, it will see updated add. It will see whether it's nullable. If it's null, it will get this one. That is why for nullable instances, for nullable properties in your model, you can do a very good thing, which calls, which can be useful only for prototype pattern. That is why, instead of doing this, you can do value getter, the foundation, use this one and do like this one. What it does, you can check whether updated that it's not null. If it's not null, you can call them. Otherwise, you can get this updated at. What does it do? For example, if you don't pass any value for this one, it will use your updated it. Otherwise, if you send something, even if it's null from outside, it would put the null here. That is why it can be null here. For example, you can send, there is a object, yeah, to do copy with, it sounds like this one. Or even you can send nullable. It will work. It will put null there, even if it's some kind of places null. So let's continue. That is why we will create our done. Updated value. We will go final update. Await. Update to do with updated to do, and we'll see if update is success. We will take our to-dos, list of to-dos. We will find, yes, final index. We'll find the final index to do's index where element id is equal, where it's equal to updated to do id. If it index is not -1, we will update index with new updated to do, and we will complete this. It should work. So let's go. First of all, we have to call this. That's good. Oh, I guess that's all. Let's check. Oh, new task 1, new task 2, new task 3. So, okay, to this one, let's check. Everything is working pretty fine. So, that is so we add the main functionality. The main functionality we added in the next videos. Probably I will show you how to write tests and how to change the same block with the freeze. And because of that, this course will take a lot of time. That is why you have to understand what's going on. Just check them. Just go from this project again and again, understand what's going on there. And if you have any question, just ask me in the description. I'll try to help you with the database, with anything. That is why remember that using Drift is very good. It has very good documentation from getting starting, from migrations, everything it has. It's very good. That's why. Thank you very much for watching. And yeah, that's all I guess.